Hello, and welcome to the 6-5 on the Road. I am Matt Kimball, Vice President and Principal Analyst at More Insights and Strategy. And today we're diving into the critical topic of data security and future-ready solutions with HPE ProLiant Compute. We're going to explore the latest Gen12 ProLiant server platform from HPE and how these systems are designed to enhance security, maximize performance, and tackle today's evolving threat landscape. I'm lucky to be joined by Scott Shaffer, VP and Chief Technologist at HPE, and Luis Luciani, Distinguished Technologist at HPE as well. Scott, Luis, thanks for joining me and welcome to the 6-5.
Hey, thanks, Matt. It's a pleasure.
Hey, so this is going to be a fun conversation, guys. You know, we talk to CIOs, we talk to IT leaders, we talk to IT practitioners on a day-to-day basis. And, you know, the conversation, while AI dominates every conversation, what is not forgotten is the challenges that exist with cybersecurity, especially when you think about AI in the hands of the wrong people, right? And what can happen. So HPE has had this reputation in the market with a well-earned reputation of being a pioneer in terms of platform level security. However, you know, with that said, new advances are coming or being introduced into the market every day, like AI. You know, we've gone from simple kind of viruses to malware and ransomware to AI being used to this new thing in science fiction called quantum computing that is on the horizon that has a lot of IT folks nervous and scared. Are y'all seeing this out in the marketplace as well?
Yeah, I would say we really are. When I think about the customers that I talk to broadly, we talk to everyone from small medium business to decent sized enterprises to federal government customers around the world to big service providers. Right? When we kind of talk to all of them, we hear all of these concerns. And when I break that customer set down, there's an incredibly large percentage of the market that what they want is they want security that they don't have to manage. Right? I think we've done a really good job of booting up a lot of these security capabilities so that they are secure by default right out of the box. And with our long history with Silicon Root of Trust, I think is a great example of that, where the ASIC itself has the secure keys burned into it during the actual manufacturing of the ASIC. Mm-hmm. And so with that, we can ensure, right, that nothing nefarious, no wrong firmware, nothing can run on the platform except for the ones that we sign. And therefore, again, that's sort of like built in, right from by default, so that it just boots up secure and you don't have to do anything.
Yeah, it's funny, you know, because you bring up something interesting when you talk about what you've done with Silicon Root of Trust, and Luis, I want to get your take on this as well. But you know, it's funny. One of the things I find very interesting is when I talk to security professionals, you know, in the IT space, they immediately go to kind of platforms that provide network level security, kind of up the stack security, right? And oftentimes that platform level, you know, server level, low level of security that really is the beginning of a zero trust architecture, they never even really think about that. It's all, you know, RDX, MDX. Never once do I hear, or no, I shouldn't say never once, but very rarely do I hear, you know, talk about those very foundational elements of security. And Luis, can you touch on that a little bit, if that's okay?
Yeah, foundational. That's the key. That's the key to it. It's really, when you're talking about Silicon Root of Trust, think of it as a tree. You know, it has to start somewhere, you know, and then build from there. So in our case, it truly is the silicon that starts. It signs, you know, this little bit of code we trust, and that little bit of code moves on to spreading that trust further and further outside of our Silicon Root of Trust to other chips, to other modules within the platform that you're talking about, and then onto the OS and things like that. So it's really it's foundational for us.
Yeah. Yeah, it's interesting, you know, because y'all did this back in 2017. That was when I think it was with ILO 5, Integrated Lights Out. your ASIC, your BMC, and I think it was ILO 5 with Gen 10. You and HPE made a splash, and you've grown the capabilities over time. And so then all of a sudden in 2020, we're in 2025, right? 2025, you launch this new platform called ProLiant Gen12 with ILO 7. And it's got some new capabilities. And I want to hit on those. But before we get into that, kind of start setting the problem statement so we can show kind of why ILO 7 and what you've done is so significant. I talked about quantum, right? What's that mean? I mean, it seems kind of like still science fiction. It's so nascent as far as the technology goes, lots of error rates, high error rates. But what's it mean for enterprise IT? Is this just a fearmonger thing, or is it legit?
There are people out there. There are people, very knowledgeable people, that do say it's science fiction, But there are people that say it. In other words, when I say science fiction, they say, well, before it gets to the point to where what we're worried about are things like can it crack an RSA key or something like that. In other words, can I get signed firmware and be able to extract what I need from that firmware in order to sign some malware and then get that onto your system. And when they say it's science, when we say science fiction, it's like, well, a couple of miracles have to happen between now and that actually happening.
Yeah.
But if you read the news and stuff, it's like they're making progress.
Yeah.
And then the people that are really worried about this stuff are the people who probably know more about this stuff than we do, like intelligence agencies and stuff like that.
Yeah.
We as a supplier to them, we are getting demands, as the whole industry is, that we have to be PQC, meet their requirements by certain dates. In other words, they want signed firmware to be PQC by 2030. And when we say 2030, it's not we need to be delivering by 2030. It's that their fleets need to be switched over by 2030.
I will, let me just click back one step. The way I try to tell people is that, should they be worried or not, right? It's kind of the fundamental question. And the way I kind of answer that is by saying, well, the current cryptographic solutions that we have are based on this idea of really large prime numbers and multiplying them and then determining what their factors are.
Yeah.
It's really what that is, right? That's the whole system of very large prime numbers, right? Super large. And we said, well, these are great because you can't factor this really large number because it would take, if you brute force attacked it, which is the only one we know how, with RSA keys, it would take more clock cycles than there are stars in the universe. That was always the thing. We said, okay, well, if we got to that scale, we're probably good. But that's where, this with quantum, there's been an algorithm developed to do this factoring in a very, very short period of time, way less than the traditional. And so near instantaneous. And I think that's what has everyone saying, wow, the current model of relying on this inability to do that factoring is about to end, with quantum being able to solve it quickly. But the good news is, the last year they finalized those algorithms with NIST, and so that was something we could adopt into our solution. Because they finalized them, we could then rush to get those deployed and into our server, so that starting in Gen 12, the systems are quantum resistant right out of the box. The information that we're talking about being protected are the things like your passwords and your keys and your configuration settings for your platform.
Tying it back to relevance today, it's that harvest now and decrypt later, right? Kind of method that you're right, that nation states are taking on to grab those secrets. That is why it should be of concern to enterprise IT folks today, and it's a legit concern. And for viewers out there, if you're kind of interested in what the government has to say, the standards that Scott and Luis are talking to, specifically around FIPS 143, I think it's level 3 certification within FIPS 140. Is that correct? It's CNSA 2.0.
So we've gone, it's 140-3
Yeah.
And then it's level. They have different levels. So level 3 is for our new product, our Gen 12.
Yeah.
Level 3 is for, we haven't talked about this, but we have a secure enclave inside of that, and
Thank you.
that's for that. And then the level 1 is the traditional ILO that's inside of there.
Yeah. But these are the adhering to these standards and these certification and achieving these certifications is what starts driving you down that path toward quantum kind of resistance or quantum. I hate to say
A,
quantum safe, but
a good
quantum.
example: the algorithms that we use have to be FIPS approved for them to be credible, right? For at least, they're compliant with the NIST specifications and
Yeah.
so on. And that's the proof we have that we're doing due diligence.
HPE did a fabulous job with Silicon Rooted Trust initially. Kind of check those millions of lines of codes and all that firmware and in your BIOS as a server is booting up. Fantastic. All of a sudden, Gen 12 comes out and you say, wait a minute, ILO 7, we're going to do this thing called Secure Enclave. Talk to that a little bit and why that's critical as part of the server boot process, and how it ties to kind of obviously greater levels of security.
It's just the threats. It's the threats have become obviously in recent times over the years have become a lot greater than they used to be. So in order to stay ahead of those threats, we have to raise the bar, and
Mm-hmm.
that's what we're doing. Look at Gen 12 as we've raised the bar significantly.
Yeah.
Not that we think there's anything wrong before. We think Silicon Rooted Trust is really industry leading. It's so simple. I mean, you look at it and look at how it works. It's like, well, it's hard to beat that.
Yeah.
But we sit there and think about, well, what are the things that we could have done better? And that's what we did in Gen 12. An example is recovery.
Mm-hmm.
Like, well, if it does find something in the early startup code, well, that code is what's needed to recover.
Yeah.
So if it's corrupt, then you don't have malware, but that's executing, but you end up with a server that's a brick, right? So what we did is in the silicon itself, it has the recovery. So code is not necessary in order to go get the backup image to get the whole thing started again.
Nice.
And then there are other little things like, okay, backup image is on this media, the main image is on that media, and all that. So you can't just attack one. You have to attack both in order to. The best you're going to get is a denial of service. You're not going to get malware executing on your system.
I think that's a really good. What Luis is bringing up is important to us because we do develop these ASICs ourselves.
Yep.
We actually design and develop them, and we care about advancing the security to meet what we imagine the threats are going to be. The Secure Enclave has its own memory and its own storage and its
Yep.
own processor that's completely isolated. It's completely isolated physically, but also electrically inside the part, so that there's a very defined interface between the code running on the main ILO chip itself and the Secure Enclave to ensure that the only interface is this very well-defined kind of Dropbox style approach where even if in the worst case scenario I can imagine, the code is compromised, you still can't get access to the secrets because they're sitting off in this completely isolated part. And that's what stores, all the secrets, right? The keys
Yeah.
and the passwords and all the crypto settings and all that stuff are all stored there to ensure that they stay safe, right? They stay in the vault kind of no matter what. It doesn't even give it to you back out. All it can do is say, you can give it a value and say, hey, does this match what's in the vault, right? You can't actually extract it. You can, the right credentials, you can overwrite or add to it, but you can't extract anything. And that's key from a security perspective.
Bear in mind that when you look at some of these, these low-level attacks, these attacks can sit for literally hundreds of days. I think the average time to recover from a malware attack is somewhere around 300 days. That is a long time that data can be siphoned off, and it's not like a bad actor injects some malware and all of a sudden opens it and starts siphoning data at large. They're very smart. They siphon off a little bit at a time, so it just looks like normal network traffic to an IT organization. And then over time, you realize, 9 months later, how devastating that attack was. That is why these low levels of protection are so critical, not just foundational because it kind of enables, up the stack, but it really protects at the most vulnerable space of that server's operating system. There is this tagline that HPE has about, from, supply chain to the cloud, security. You talk about kind of the one element of that, but, do one of you want to kind of hit on kind of the integrity you build into supply chain and manufacturing, secure manufacturing all the way out? Because I think it's a interesting but often overlooked kind of element to HP's strength.
I would say that zero trust comes into play a lot here, and it's not just the buzzwords. A good example is that we don't trust the factory, and we don't trust any of the supply chain. It's inherent. Like an example is that we talked about silicon root of trust. It's spreading all over the place. There's a lot more to it than just that. It's authenticating all the different parts in there. We're also doing through attestation, making sure that it's not only valid firmware, it's the version that you expect, that's on there. And we're keeping an inventory of everything in what's called a platform certificate, which is industry standard. But we build that, we sign it through our signing process. So the factory's not trusted. This blob goes to our signing service. We sign it and send it back. The inventory is done by our silicon that's on the server, not some factory process or anything like that. So I think that goes that sort of describes our thinking behind all of this kind of stuff is when we do that. So when it arrives, we didn't rely upon the shipping company or anything like that.
So in addition to all of the technology that HPE has developed and employed, and processes you've employed or deployed for to assure this secure environment, I'm an enterprise IT person. I'm listening to this and I'm like, oh man, I should just quit right now and go to a beach and never think about technology again, right? What are the, 3, 4, even if it's just a couple things that, if I'm an enterprise IT person, I should be thinking about to get kind of future proofed with my infrastructure?
Yeah,
I'll
well,
let
I
you
mean,
start.
I guess my first thing is, look, we've endeavored to make these systems as automatically secure as we possibly can, so that you don't have to do something. What you what you would do is deploy, for example, our brand new Gen12 servers. They're secure by default, right? They come right out of the system with the high security enabled, and for a good reason, right? So that you don't have to, as a customer, you don't have to do anything. And you may want to take a hard look at some of your existing systems and see if they're not up to the level that you would like them to be for the threats that we see today, and refresh those systems with replace them with a Gen 12, and know that it's secure like right out of the gate. And then, I'd say that's your first thought. I can't impress upon people enough the value in keeping current from a firmware perspective, making sure that you stay updated. I know it's not sexy or exciting to update the firmware, but to be fair, if you don't, you're not going to be protected from the emerging threats. That one other add-on is that I'd mention is that all of the ProLiant Gen12 servers come with a license for HPE's Compute Ops Management solution. From a security perspective, you can see right there what is the security posture of all of your servers. If any of them are at risk, you can see that immediately. You can change the at-risk policy, so you can define that for what's appropriate for you. The all the settings are be able to be configured right there. So if you want to change a setting and reconfigure it, you can, and do so at scale. I cannot impress enough among this is an at scale kind of a tool, and we do see lots of compute at the edge. For us, I would mean out at retail stores, out at manufacturing sites, and warehouses, and all kinds of places. And so we don't want to send in people out there, to change the security setting. We can do that all remotely with Compute Ops Management, but more importantly, we want you to be able to check them. We want to be able to check their posture very easily from a central location, without having to visit them, right? And so That's what the solution provides, and that gives you that full kind of view, right? From it was delivered to you safely, you deployed it securely, it's operating correctly, and I can check it and keep it up to date.
I think it's important for enterprise IT folks to understand that just as the threat landscape is evergreen, it's always evolving and it's always looking slightly different and regrowing. So should your cybersecurity strategy, right? You don't write something in the year 2020 and assume that's going to be relevant in the year 2024, 2025, or 2030. You've got to constantly look at what you're doing from a technology, operations, and organization perspective. And I think when folks do that, that's when the need for ProLiant Gen12 or Gen12 ProLiant, ILO 7, becomes apparent because you start to understand the evolving threat landscape. Thanks for joining us for the 6.5 on the road as we explored securing data with the HPE ProLiant Compute platform. Be sure to subscribe, follow us on social media, and check out all of our coverage at 65media.com. See you next time.